Okay, second part of the quiz here. On this problem it says to find the apothem, perimeter, and area. And we've got a hexagon. That's 6 sides there. This one of the sides is 6. So the easiest part of this problem is the perimeter. You have 6 sides and they're all 6 long, so that's 36 for your perimeter. I didn't grade units, but it'd be centimeters because you started in centimeters. Okay, in all these problems, you need to draw a picture of your central angle triangle. It's going to have that 6 along the bottom. I didn't leave much space there. And it's going to get cut into 2 equal pieces that are 3 and 3. Always gets cut into equal parts because this is an isosceles triangle. There's the radius. And the apothem is the guy coming down the middle. We need him. If we get the apothem, we can get the area. Well, we've been using trigonometry. The measure of our central angle, I'll put this over here. Measure central angle is 3. That's hard to read. I'm going to write that again. I'm sorry. The measure of the central angle. 360 over the number of sides, which is 6. That's 60. Now that 60 gets divided up. That's really the whole angle up here. It gets divided into a pair of 30s. Okay. We have been using tangent with that. We said tangent was always opposite over adjacent, so the tangent of 30 is 3 over A. That means that A and tan 30 will switch places, and my apothem is 3 divided by the tangent of 30. And I'm not going to convert that to decimal because I want to be accurate to the nearest tenth on my final answer. If I convert to decimal now, I'm going to lose accuracy. So I'm just going to leave this as 3 over the tangent of 30. If you did feel you needed to make that a decimal now, you could write it as a decimal, but when you do your calculation on area, go back to 3 tan 30. 3 over tan 30. So now I'm ready to get the area. Area is 1/2 the apothem. Well, that's the 3 over the tangent of 30 multiplied by the perimeter. And the perimeter was 36. All right, maybe that making that a little larger helps a little bit. So that's 1/2 3 over tan 30 times 36. And we just grab our calculator there. In my head, I'm going to cheat a little. That's a half of 36 is 18 times 3. This is the same as 54 divided by the tangent of 30. And this is 93.5. We weren't asked for units, but we had to put them in. They would be square centimeters. Okay, next problem. We have same sort of problem, just starting you a different place. This time we're starting you off with the apothem. And it goes from the center, forms a right angle with the side. So that is the apothem there. We have 5 sides. So the measure of our central angle this time is 360 divided by 5. 360 divided by 5 is 72. So when I draw my central angle triangle this time, I've got a 72-degree central angle that's getting split into 36 and 36. Got my apothem here at 10. I always got these 2 equal pieces on the bottom that make up a side, which is twice as long. Alrighty. So now, again, it's tangent. Tangent of 36 is x over 10. If I multiply by 10, I'll get x equals 10 tan 36. Now that's not a complete side length yet. I'll multiply by 2 to get that because S is 2x. So S is 2x. It's 2 times 10 tan 36. Or the side is 20 tan 36. You could leave it like that if you wanted. If I'll go ahead and write it that way, 20 tan 36. You could convert it to decimal here if you'd want to, but if you convert it there, when you do your area calculation, go back and reuse the 20 tan 36. That'll keep you accurate. All right, we're ready to go. We need the perimeter. This guy's got 5 sides, so his perimeter is 5 times 20 tan 36. Hard to read. I'm getting writing too small. Finally, the perimeter. 5 times 20 is 100. 5 times 20, sorry. That would be 100 tan 36 for your perimeter. So now you're going to use your formula, 1/2 PA. So we have the area, or 1/2 AP, is a half of 10. That is your apothem, times your perimeter, which is this 100 tan 36. All right, and we're just going to put that in the calculator. In my head, I know that half of 10 is 5 times 100. That's the same as 500 tan 36. Gives me 363.3. I'm going to, right there, I'm going to get rid of that equal 72. That's from something else earlier. Okay, there's your answer. Units, that'd be square inches, but we weren't asked to give them, so we'll let her go. Okay, problem number 3. And I've already used the answer space there, so I'm not going to write the answer down there. I'll just write it below. Okay, so what you've got here is you have what would be a rectangle if it was filled in. The dotted lines mean they're not really part of the diagram. They're just extra information. Yeah, and what we've got in that area is a 14 down here. The side length is 25, and the other side length is 11. Okay, so what we've got here is a rectangle with a triangle being taken out of it. So the area of the figure that is solid here is equal to the area of a rectangle minus a triangle. Well, the rectangle is 25 by 11 if it was all filled in. So that's 25 times 11. I'll subtract the area of a triangle. Triangle is 1/2 base times height. So 1/2, if I move that 11 over here, because the outside's a rectangle, opposite sides will be equal, the 11 will be the base and the 14 will be the height. So 1/2 of 11 times 14. That whole calculation then can go into the calculator for number 4. So I have 25 times 11 minus 1/2. I put 0.5 in my calculator. Times 11 times 14. 198. It comes out exact. So we've got 198 right here. Oops. Right here, it's number 3. I don't have room on the answer blank. 198, and it'll be square centimeters. All right, problem number 4. We've got a rectangle in here with a half a circle being added on. Okay. Now, all the way from one end to the other is 7. These two guys are equal. And here's the key. If this piece is 4, then this piece all the way here is 4, which tells me that the diameter of the circle must have been 4. It gets divided up into 2 and 2. It also shows me here's a radius right here that would be 2. Now if I take 7 minus that 2, it leaves me these sides at 5 each. So on number 5, let's work that out down here. What I have is the total area is the area of a rectangle plus the area of a semicircle. Well, the rectangle was 4 by 5, so that's 4 times 5 for its area, and the circle had a radius of 2. So its area would be pi times 2 squared, but since it's not a whole circle, it's just half a circle, I'll divide that by 2. So that's going to give me 20 plus 2 squared is 4. That's 4 pi over 2. That's 2 pi. And we're going to go to our calculator then. 20 plus 2 pi. Oops. 20 plus 2 pi on my calculator is 26.3. So 26.3, and that would be square inches. Okay, on our last guy, we just have something that's made up of 3 parts. It's made up of a 5 by 10 rectangle, so that area is just over here, just for the heck of it, so you know. That was number 3, what we were doing, and this was number 4. This is number 5. It says Layla needs to buy grass seed for her lawn. Her lawn's in the composite figure. What is the area of the lawn? Okay, so we're basically trying to figure this area here. This piece is 5 by 10, so this is problem number 5. This piece is 5 by 10, so its area is 5 times 10 because it's a rectangle. In the middle, we got to do a little detective work. This section is 2.5. That section is 5 because it's the opposite side of this 5 over here, and there's another 2.5. If I add those all together, I get 10 for the up and down distance on that rectangle. So plus 10 times across the bottom was 20. And lastly, I've got to add the area of that triangle. Well, because it's a right triangle, the 2 legs can be used for the base and height. So I'm going to go plus 1/2 of a base of 15 and a height of 6. So what do I have? I have 50 plus 200 plus, this would be 3 times 15, it would be 45. And that's going to be 295 units square feet. So to get the area of things made up in pieces, you add the pieces together, or if a section's been taken out, like in this one up here, you subtract a part off. All right, I hope that all was so you could see it on the video okay. There's my solution on number 5. Here's my solution on 4. And right below it is my solution, 3 rather, up here, and 4. Okay, well, we'll play them tomorrow in class and see if they turn out good.